Now for our next comparison, what we might do is try to combine a couple of independent variables, such as age, Thal-Asch, which is maximum heart rate, and then compare them to our target variable, heart disease. So if we have a look back at our data frame, so what we might compare is age, Thal-Asch, and target, all in one. And now if we go to check our different values for Thal-Asch, now the reason why I know this is max heart rate is because if we come back up in a second, so we can see there's a lot of different values here. So the length 91, if you call value counts on any column and the length comes up as something, that means that there's that many different values in that column. So what that might be telling us is because there's so many different values, looking at it on a bar graph may not be the best type of graph, because if we look at this plot, there's only 4 columns here and that's pretty interpretable. But when there's 91, that might be a bit harder to look at. So that's where we might bring in something like a scatter graph. Let's go back to our data dictionary and have a look at what Thal-Asch is. Come up here. Thal-Asch, maximum heart rate achieved. And again, we're really just diving in, reading our data dictionary. Here you might just go through different columns, read them, which ones stand out to you, and try to compare a few of them with the target variable. And remember, if we come back to our data frame, these are often referred to as features or independent variables, and this is often referred to as the target or dependent variable. So that's what we're doing here. We're comparing independent variables to our target variable. This might seem a little as if we're jumping all over the place, and I know I've said this before. It's because we are literally just picking columns here that spark our interest. This one sparked my interest, and we're trying to figure out how they relate to the target. That's what we're doing. You may choose a couple of other columns. I'm just going through the ones that look most interesting to me. So let's make a little heading, age versus max heart rate for heart disease. And then we'll turn that into Markdown. Beautiful. So to compare 3, such as age, Thal-Asch, and heart disease, what we might have to do is create a plot with 2 plots on it. So let's start off first by creating another figure, plt.figure, and we'll pass it a fig size equals 10:6. Then we might go scatter. We might do a scatter with the positive examples first. So just bear with me for a second and we'll talk through what's going on while we're going through it. So plt.scatter, we want to see on this scatter the positive examples. So we could go df.age or df.age in brackets. They really mean the same thing, but I like to do it this way, df.age, and then in here we're going to do df.target equals, of course you couldn't do this if your column names had spaces in them, but in our case none of our column names have spaces. What this is doing is a subset of the data set. We're taking the age column from our data frame where this condition equals true, so where the target equals 1. So if we did that in a cell below here, df.age, df.target equals 1. So this is going to show us all the age columns where target is equal to 1. So that's what we want. Beautiful. And we also want df.Thal-Asch, which is maximum heart rate, df.target equals 1. Beautiful. And we're going to give it a color of salmon. What would this look like if we called that? Wonderful. So along here, we've got maximum heart rate and we got age. So what could you infer from this pretty quickly by just looking at it here? Well, you might infer that there's kind of a downward trend. So if you were to draw a line through there, just a straight line, it's all over the place, right? But it's you can kind of see the pattern going down here. The younger someone is, the higher their heart rate. That's the kind of trend that you'd be seeing there. That makes a little bit of sense, right? Now, these are positive examples. So these are patients, because we've got target equals 1, these are patients with heart disease. And so now we want the negative examples on the same plot. So scatter with negative examples. I'm going to go plt.scatter. I'm going to go df.age. All we're going to do is just copy what we've got above, but except target equals 0 because they're negative examples. This is without heart disease. Phthalac df.target equals 0. Wonderful. C equals, I'm going to go light blue. That's the color scheme we're set up for now. Beautiful. So now we've got positive and negative examples on there. And again, they're kind of all over the place, but if you were to look at the trend, the line kind of goes down for both. But again, you can't really split them. This is where our machine learning model will have to take over from our ability to have a look at this. So if you were to look at this, I just put a semicolon there to stop that little matplotlib output. If you were to look at this and you try to decipher what's going on here, what was the maximum heart rate of someone who had or didn't have heart disease? The salmon versus blue dots. Blue dots are without heart disease, salmon are with heart disease. If you had to decipher this, it'd be pretty hard, right? Because these are all so mixed up together. Maybe you might infer that there's some sort of pattern. There's a fair big cluster here. There's a big cluster here. But really, I can't really tell a pattern. Maybe if I had some more time to look at it, I could find something. But this is where machine learning is going to come into play. The patterns that you can't necessarily see straight away, machine learning is going to dive into the data. It's going to form some calculations and figure out these patterns that we can't really see. Again, if we had enough time, maybe we'd find something. But we're machine learning engineers, we're data scientists. We prefer that the algorithm does the job for us. So what we might do is add some helpful info just to make this plot a little bit more complete. So plt.title, heart disease in function of age and max heart rate. And then plt.xlabel, down the bottom is the age. And then plt.ylabel, this is going to be max heart rate. And then we'll add a legend so people can understand which dot is which, and they're not just thinking about, whoa, what's going on here with the salmon and light blue dots? Amazing color scheme, but I'm not sure what's happening. And we'll put the semicolon there instead of there. Wonderful. So that's looking a little bit better. But again, you let me know if you can see some sort of pattern. But to me, all I can really see is a bit of a downward trend. So as someone gets older, their maximum heart rate decreases, which kind of makes sense. Again, when you're exploring a data set, you won't necessarily always find patterns to begin with. We're just familiarizing ourselves with what's going on. And so because we've just done the age, what we might check out is what's the distribution of the age. So to do so, we'll go check the distribution of the age column with a histogram. Now the distribution is another word for spread of the data. So we can kind of see here that there's almost an even spread. So you may recall what kind of distribution an even spread of data has. And if you don't, that's perfectly fine. It took me a while to understand this as well. It took me a long time actually, and I still have to research. So this kind of distribution here is otherwise known as a normal distribution. And if you were to really say what kind of normal distribution is, we'd look at this perfect normal distribution. Let's have a look. Let's go normal distribution is going to look like a bell curve. So see something like that. So if we come to ours is very close to that shape, but it's kind of swaying towards the right. So we can see that most of our population or most of our samples, their age is around this big mid gap here. And we don't have that many around the 30-year-old age or past, this might be 80 up here or something like that. We don't have many past there. The majority of our data set are within the 50 to 60 range. And so this is what you might want to do for a bunch of different columns, is check the distributions, check the spreads. If we did have someone out here that was like 150, that would maybe be some type of data that we'd have to clean up, because I'm not sure if anyone's ever lived to 150. Or if we had someone down here that was maybe 5 or something like that, we'd also have to think about, okay, is that something we want to include in our data set? But this is going to be different column to column. So we're just checking the age here. It's a normal distribution. We might do the same for other columns, but the way you sort of think about samples out here is they're referred to as outliers. And now, how will you tell that if there's any outliers? Well, distribution plot, this histogram, is one of the best ways to do it. So if you're getting some weird results, like some weird results in terms of your machine learning models later on. It may be because there's outliers in the data, and that's where you'll have to check different distributions of each columns. So that's one way to do it. Now, what we might do is compare another two columns. So if we come up here to our data dictionary, I saw this one before, the chest pain type. And I thought that would be interesting to see. So if we got here 4 different types of chest pain. So chest pain related, decreased blood supply to the heart, chest pain not related to heart, typically esophageal spasms. So I guess that's like your esophagus, which is, I think, that tube from your mouth to your stomach or something like that. Asymptomatic, chest pain not showing signs of disease. Okay, so this will be pretty interesting, right, if we compare this to the target column. So chest pain versus target. So does chest pain relate to whether or not someone has heart disease? So let's come down here. We'll go make a little heading. Heart disease frequency per chest pain type. And what we might do actually is just remind ourselves, copy our data dictionary for chest pain so we can remember what each different value is. So if we come in here and we'll copy this, Shift and Enter, we'll bring it down and we'll paste it here. Wonderful. So this is what we're going to compare. We can do that with fairly quickly with a PD crosstab, df.cp, df.target. Okay. So if we look at this, what would we devise in here? It seems as chest pain goes up, so does whether they have heart disease. But if we get 0 chest pain, there's a lot more that don't have heart disease than do. But if we get 2, there's only 18 with 0, so don't have heart disease, but 69, so nearly over 3 times the amount that do have heart disease. So this is non-adrenal pain, typically, non-heart related. Well, that's interesting that it's non-heart related. And so these are the type of patterns you'll start to find out in your data. Some make sense. That doesn't really make sense to me. Non-heart related pain, yet more people have heart disease with 2 than not. And so these are the type of things you might be wanting to discuss with a subject matter expert. If you're looking through a data set, such as us looking through this heart disease data set, and I'm not a doctor, I'm not trained medically, I've researched some things about health, but I've no idea about chest pain. So if I got this data set of someone from a medical profession, I'm trying to use machine learning to figure out whether someone has heart disease or not, and I'm coming across these patterns that I don't really understand, that's where I'd probably reach out and go, hey, to a medical professional, or I do my own research, such as looking up what these actually mean. We did that before, defining angina. Going, hey, I'm seeing this in the data, but can you shed some light? It's kind of confusing to me. Is this correct? Is this not? That's the kind of the insights that we're looking for, is both patterns that make sense to us, such as the normal distribution of age, such as the declining max heart rate as someone gets older. This one maybe doesn't make as much sense. Is heart disease more prevalent in women than it is males? So this is the type of questions that we're trying to get. We're trying to formulate an idea in the data by not finding answers, but finding questions that we can ask. And so what we might do is make this a little bit more visual, as we've done before. Make the crosstab more visual. PD crosstab df.cp df.target. We're just writing what we've got above there. .plot. Same plot again. We might do a bar because there's 4 different values here versus 2 different values there. So we should be able to look at it fine on a bar graph. Fig size equals 10 and 6. Wonderful. And we're going to use our favorite colors. Color equals, what are we using? Light blue, salmon. Actually, I think the order was the other way around. Maybe we did salmon first, then light blue. Doesn't really matter. Beautiful. Then we're going to add some communication. plt.title. Heart disease frequency per chest pain type. Then we go plt.x label. I'm going to do chest pain type. And then on the y is plt.y label amount. Beautiful. plt.legend. We're going to put on here no disease, disease. And then we'll finish it off with, again, we're going to make sure that the X ticks are vertical so it's a bit easier to read. Shift and enter. What do we got? PyPlot has nothing. Y label. We got a little typo. Beautiful. There we go. So that's a bit more visual. So there we're just turning our crosstab into a graph here. Now this is something that we could take pretty quickly to someone and go, hey, what's going on here? Chest pain type has way more accounts with the disease than chest pain 2, that is. And it's supposed to be non-anginal pain. So typically esophageal, that word is very hard for me to pronounce, esophageal spasms, non-heart related. So this is, again, raising questions from the data. That's what we're trying to do in this exploratory data analysis. All right, so we've got a pretty visualization there. What we might do next is check out the correlation between independent variables and our dependent variable. So again, if we have a look at our data frame, this is what you want to be jumping in and out of, right? Just using df head to quickly have a snapshot of your data frame. These are our independent variables, remind ourselves, and we're trying to use them to predict targets. So we'll see how we can compare those, and we're going to use a correlation matrix, but we'll see that in the next video.